friends, my name is Dinesh Singh and I welcome you all to Study Nation, our YouTube channel. And today we are going to start with the topic gate calculus, and where we are doing the topic continuity. And what I will cover today in this topic, I will say what is the definition of continuity, then what is the discontinuity mean, and what is the use of the continuity. Then there are different type of discontinuity. So generally gate does not ask which type of discontinuity. They will ask either the function is continuous or discontinuous. Then the property, if the function are continuous, then there are some difference, product, division, or maybe some power are also continuous. And there is another theorem which is known as a mid value theorem. Okay. So generally just remember, in gate question, continuity does not come alone. Most of the time it comes with the differentiation. So first I will tell you what is the continuity, then I will define the differentiation, the part which we will use in the continuity, and then we will define what is the role of continuity in differentiation and how they are combined together, and the question based on the continuity and differentiation. So let's see first define. So if I will say continuity, so continuity means continuous. There is no break. So let's see what is the meaning. So we will say continuous at x is equal to a. So we will say a function is called continuous at x is equal to a if limit x goes to a, f x is equal to a. So this contains both the limit, which is a left hand limit, as well as right hand limit, and which is equal to the value of function. So means the limit of a function at x is equal to a must be equal to value of function at x is equal to a. Okay. So what is the meaning of that? So suppose we are saying there is a function. We are saying function is defined like this one. Now there is a point. We are saying this is the point. X is equal to a. Now this is the left hand point. X is equal to a minus h. And we can say the right point is x is equal to a plus h. So if we say limit h goes to 0, so there are two different ways to reach x is equal to a, either from the left side or either from the right side. So means we are reaching from left side and we are reaching from the right side. So this is the left hand limit reaching from left hand side. This is the right hand limit reaching from right hand side, and this is the value of the function. So just remember, all these three should be defined and they must be equal. Okay, so we are saying the meaning of that is what? Suppose you are talking a particular point x is equal to a. I am coming from left side, I am coming from right side, and the function's value is equal to the value of the limit. So if they are equal, so it is coming to L, it is also coming to L, and the value of the function is also L. So it is going without any break. So if function is not defined, the limit is defined, it is not continuous. If the limit is defined and they are different, again it is not continuous. Suppose the limits are same, left hand limit and right hand limit, but they are not equal to the value of function, again function is not continuous. Okay, so let's see how we will check. So we are saying this is the value of function, we are saying fa, and this is the left hand limit, right hand limit. So if they are reaching to same L and L is equal to fa, then we will say function is continuous. So let's see the example. Suppose I say fx is equal to x square minus 9 divided by x minus 3 if x is not equal to 3. If somebody asks you what is the point where you have to check the continuity, so the same way I have defined for limit, the value where the function changes its definition, or function is not defined in the case of the limit, but in the case of the continuity you have to check the point where function changes its definition. Because if function is not defined, means this is not defined, we cannot check continuity. So suppose this is the first case we will say if we take the limit x goes to 3, x square minus 9, x minus 3, using the L'Hopital rule, this is a 2x which is equal to 6, but function is not defined, so we will say limit does not exist. So this is the case 1. Let's see the second case. We are saying fx is equal to x square minus 9, x minus 3, where x is not equal to 3. So we are saying and 7 when x is equal to 3. So it says the limit is equal to 6, but this is not equal to the value of f3. So we will say again function is not continuous. Now understand in this way, we are saying suppose you are reaching from this point and this point, both the point are giving to the value of 6, but the value of function is 7. So means the function from the left hand side reaching to the 6, right hand side again it is reaching to 6, but the value of the function is 7, so it is reaching to 6 and then jump, then there. So we will say this function is not continuous. Okay. Now the third case, we will say fx is equal to x square minus 9x minus 3 if x is equal to not equal to 3 and is equal to say x is equal to 3. So we will say left hand side we are reaching to 6, right hand side we are reaching to 6, and the value of the function is again 6. So there is no break and the function is continuous. So this is the example where function is continuous. Now very simple funda. How to calculate this one? We will say just calculate the limit and put the value. If all three are equal, then we will say function is continuous. If they are not equal, function is not continuous. Okay. Now let's see some examples of discontinuity. First, we are saying jump. So suppose if we are saying is the greatest integer function, or we can say the floor function. So check at any integer. We are taking a limit x goes to 5. So we will say 5 plus h is equal to 5. 5 minus h, limit h goes to 0, limit h goes to 0, and limit 5, this is equal to 4 and this is equal to 5. So means whenever you are reaching from the left hand side, the value of the function is 4, but as soon as you reaches to the value 5, it is goes to 5. So means there is a jump in the value, so that's why we will say this is known as a jump discontinuity. Okay, so we cannot make this function continuous because there is a break or there is a jump. Second, we will say infinite discontinuity. So suppose the function is defined as f so we will say if we take from right side, so it is positive 1 upon infinity, 1 upon 0, it will goes to infinity. So means x is equal to 2, it will come from the infinity. If we say 2 minus h, it will reaches to what? So we will say again the value is this one. So means the function is discontinuous at x is equal to 2 because it gives you the value infinite. Okay, so we cannot calculate the limit and we are saying this is a discontinuous function. Simply third, oscillating. So suppose it is written as sine 1 upon x. So now it is discontinuous at x is equal to 0 because we don't know the value of sine x. We know always 1 and minus 1 between, but we don't know what is the value of 1 by x, because if x reaches to 0 it can be anything and the value of this can be anything. So we will say the value varies between minus 1 to 1 and the value of function is oscillating. So that's why it is known as the oscillating discontinuity. And the important is the removable. Removable means suppose it is written as fx is equal to x square minus 4x minus 2x is not equal to 2. Now, because the function is not defined x as x is equal to 2, but the limit is defined. So what we can say, we can remove discontinuity by defining fa is equal to limit x goes to a fx. So means if we take limit, here we will get the value 4. So if we define fx is equal to 4 at x is equal to 2, so we have removed the discontinuity and the function is continuous. So this way we say the function can be made continuous. So removable is important because we will use this in the part of complex function. Okay. Now there is a theorem which says suppose f and g are continuous function, then f plus g, f minus g, f into g, f divided by g, given that g is not equal to 0, and f raised to power m by n, where m and n are integer, n is not equal to 0, also continuous function. Okay, so you can check the continuity at a particular point, or maybe you can check in the interval. So suppose somebody wants to check fx continuity in interval. So suppose somebody wants to check for fx in AB. So we don't know the left of A, so we will say at each fx is continuous at x is equal to A, right continuous, because we don't know the left value. So the value of function at A is equal to the right limit of this one, and similarly at x is equal to B, left continuous. So now another theorem is the mid value theorem. Suppose fx is continuous in A to B and A less than FB, and I am saying there is a value V and V is, then there must be at least one value x is equal to C such that fc is equal to v. So what is the meaning of that? Let's understand in this way. I am saying, suppose this is the x is equal to a and this is the x is equal to b. So what we are saying, this is the value fa and we are saying this is the value fb. So means in continuity I am reaching from this point to this point without any break. So suppose I am reaching this way. Okay. Now we are saying there is at least one value v. So we are saying this is equal to v, fb, this is fa. Now there is a v. So we will say this value is a v. Then there must be a function, there must be a x is equal to c at which the value of the function is equal to v. So means because it is continuous, so if it reaches from fa to fb, definitely it touches the v function. And if it touches the v, there is at least one value between a and b which is equal to c and fc is equal to a. So this is known as a midpoint. So if we are going from 1 to 2 in the value of function fx, then definitely there is at least one value c such that fc is equal to any value between 1 and 2. Okay, so this way we can solve it. Now, if somebody says, suppose I have to check fx is equal to mod 5x minus 3. So we will say this function is defined everywhere, but we have to check only at 3 by 5. Because at 3 by 5 it changes its definition. So we will say fx is equal to 5x minus 3 if x is greater than equal to 3 by 5 and 5x minus 3 if x is less than 3 by 5. So there is no need to check the limit, just put the value of 3 by 5. So if you put 3 by 5, so 3 by 5 into 5 is equal to 3 minus 3, it is 0. Here also 3 by 5 minus 0. So they are equal, so function is continuous. So we will say to check continuity it is very easy. So put the value of function, check if the left hand limit, right hand limit and the value of the function, if all three are equal, function is continuous. So from this we can say any polynomial of x is always continuous at each point. Mod ax minus b is always continuous. And remember, if the limit exists, it is not necessary the function is continuous, but if it is continuous, 100% limit exists. If limit exists at x is equal to a, then fx may or may not be continuous, may or may not be continuous. At x is equal to a, but if fx is continuous at x is equal to a, then limit must exist. So means continuity is more restricted than limit. So if limit exists, then only we will talk about the continuity. So I am taking an example. Suppose a function is defined as x square minus 3 if x is equal to suppose somebody asks you have to check the continuity. So where I will check the continuity? I will check the continuity at x is equal to 0. So if I will put x is equal to 0, we will get 0 here, 0. So we will say 2x plus 4 is 0 and 4 minus 3x is equal to 0. So it is continuous at x is equal to 0. Now what about x is equal to 1? We will say x is equal to 1. This is the one definition, this is the second definition. So we will say 1 square minus 3, which is equal to minus 2, and 1 into 2 plus 4, which is equal to 6. So they are not equal, so we will say not continuous. So simply this way we can check the continuity. And suppose somebody says fx is equal to x square minus 5 if x is not equal to x square minus 8 and x minus 2 root 2, if x is not equal to 2 root 2, and so then find the value of b if fx is continuous at x is equal to 2. So I have changed the question, x is not equal to 2, and then I am saying x is equal to 2. So we are saying if it is continuous, so if we will check the limit, what we will get? We will say 3x square upon 1 and limit x goes to 2, which is equal to 12. Now this should be equal to the f2. f2 is equal to 12, which is equal to 2 square plus 4b, and you will say 12 is equal to 4 plus 4b. So 4b is equal to 8. So b is equal to 4. Sorry, b equal to 2. So we will say this way we can check the function is continuous, then we can calculate the value. Okay. So I hope you understand this part of the continuity. In the next, I will define the differentiation, and then I will solve the question based on the differentiation and continuity. So if you like our lecture, please subscribe our channel and share it with your friend. Thank you very much.